Static characteristics of SCR. This is also the hardware experiment, and here we are going to find the latching current of the SCR and its holding current and its on-state resistance and breakover voltage. So for this, the construction of the circuit is like this, and we need to plot the graph of voltage across this anode and the cathode and the current, that's IA, that's the through anode through SCR, that's IA. We need to plot the graph of this VAK versus IA, that is called as the static characteristics of this SCR. So how to draw this graph? Initially we need to set some gate voltage, that means gate current IA, that should be a constant. So here we have one RPS which is connected to the gate of the SCR. So here by changing the RPS voltage we need to set some gate current. That means for a SCR usually we use 3.12 milliamps or 3.16 milliamps, like that. We need to keep some current here to the gate terminal, that's IG. Let's say here 3.12 milliamps, okay, milliamps. Here the current, this is a hardware experiment, hardware, simply I am showing like this, okay. Here it's a 3.12 milliamps. Now don't touch that RPS that's connected to the gate terminal. Then now we need to measure the latching current. Initially now we are going to measure the latching current. So for that, what is this latching current? Latching current means it is the minimum forward current that has to be maintained in order to switch the SCR from its forward blocking state to the on state, that means conduction. Forward blocking state means though if we are connecting the gate current, the SCR, for a small value of this current, that means IA, current through the SCR is very small, at that time this SCR will not conduct. So the minimum current that we need to maintain, that has to flow from anode to the cathode, we are not touching this. This is 3.12 milliamps itself, the minimum current that has to flow from this anode to cathode, such that the SCR should be changed from its forward blocking state to the conduction state, on state. On state means after that, when the SCR reaches the on state, if we remove the gate also, it will conduct itself, it will conduct, that is the on state. So now how to do that? This we kept 3.12 milliamps by changing this RPS voltage. If we change this voltage, then this current also changes, no. So we need to set this 3.12 milliamps by looking at the ammeter, and after that we need to increase this RPS which is connected to the anode and the cathode, connected between anode and the cathode. We need to increase this in a step, small steps. Initially the RPS voltage, that is voltage VAK, is 0, okay. Then I am increasing that RPS voltage. Then we need to observe the current across this anode, the current through the anode, okay. Yeah, we need to measure the current through this anode. Then okay, here is the my measurements, that means reading. Here IG I kept 3.12 milliamps, and VAK, that's my RPS voltage, that's I'm increasing in a small step. So for 0 volt, 1 volt, 2 volt, I am getting the IA, that is current through the SCR as 0. It's because here you can see the SCR, initially the SCR is in a forward blocking state. That means it is blocking, it is not allow the current to pass through. So the current is 0. If you measure the voltage across this anode and the cathode, then we will get the voltage that is somewhat the RPS voltage itself. Some voltage drop across this resistor, but we are getting the voltage across anode and the cathode. The voltage is not 0. We are getting some voltages. You can see here, yeah, it is my 0 volt, 1 volt, like this. If you measure the voltage also, that's the same, that's the RPS voltage. Then the IA is 0 because the SCR is in a forward blocking state. Then I'm going to increase this SCR's voltage across this anode and the cathode step by step. Then at certain voltages, here let's say here 6.4 volt, I am getting the 0. After, when I increase a small voltage also, suddenly the voltage drops to voltage, there will be a huge drop in the voltage and the current increases 53.6 milliamps. That means, okay, yeah, that means here at that time when we get the huge increase in the current and drop in the voltage, at that time this SCR, it switches from its forward blocking state to the on state. So on state means if you measure the voltage across this anode and the cathode, it's a very less because the current is flowing. If you measure the voltage across a closed path, then it's 0. So that voltage is almost 0.7 to 0.6. We are getting like this, no? 0.7 to 0.72. This much less voltage we are getting. Voltage across anode and the cathode. But the current through the SCR is increases suddenly. That means it switches from its forward blocking state to the on state. So which is the latching current now? In this reading 53.6 amps, no, milliamps. This is the latching current we are getting for Ig equal to 3.12 milliamps. That means at that current means 53.6 milliamps, that minimum current is required to make this SCR from its forward blocking state, to switch this SCR from its forward blocking state to the on state. If we pass greater than that 53.6 milliamps current, then the SCR will remain in the on state, although if we remove the gate connection. That is the latching current. Don't going to change this VGG. We just need to change this VA, that is across anode and the cathode. We need to just step by step increase this.